Okay, student. Today I will explain you some problems of Fourier transform. Here, the example 4. By using the Fourier sine transform, solve the partial differential equation. The question is like that: del v by del t is equal to k del 2v by del x2 for x greater than 0, t is greater than 0, and under the boundary conditions v is equal to v0 when x is 0 to greater than 0, and initial condition v is equal to 0 when t is 0. Okay, now to solve this question, we take the Fourier transform on both sides. Yes, we apply on here is one side. So this can be written as, yes, d by Fourier transform del v by del t sine of px dx and k time del 2v by del x2 sine px. Yes, students, now. So operating here, this can again be written as d by dt of, yes, integral from 0 to infinity, yes, v is sine px dx, yes, and again here is equal to, yes, d2x by, that is this integrating by parts, so this can be written as, yes, k times, yes, and here this can be written as del v by del x, del v by del x, and also sine px. Okay, and the limits from 0 to infinity, and minus of, or you can say that next, okay, minus of here k, and also integrating of this, differentiation of this is, okay, so this is equal to p, okay, and here is again 0 to infinity, yes, del v by del x, and here is cos px dx. Okay, students, yes, clear, and also this is one of this is, and now here it also is given as del v by del x, yes, here is this one. Okay, so this is again is equal to, yes, solving this equation we get d by dt, d by dt, yes, 0 to infinity v sine px dx is equal to minus, yes, here if you take this, because you will get here is minus of k, yes, and taking the limit from here is also, and here is also cos px, integrating further v, okay, further will be, if you integrating this then v, and this cos px, and again we will get v sin px, yes, okay, so this can again be written as, yes, after further integrating we get this is this minus 2 minus k, here is minus k p, okay, and integrating this one, then you get this, you get here is v cos px, yes, clear, v cos px, limit from 0 to infinity, and now integrating again this one, then we get minus of k p square, and this one become 0 to infinity, yes, v sin px, yes, sin px, this one sin px and dx. Okay, student, so sin px dx, So this is again is equal to yes, or we can say that this is equal to so we say that this is equal to minus p. So this is again here is 0 to infinity, so we get 2 k, yes, here is kp as u tends to 0. Okay, here the condition is given when v is equal to v0, when x is equal to 0, and again v is barabar 0 when t is equal to 0. Okay, so again, so we get here is this, we get minus k, yes, minus k p square v s, that is Fourier transform of sine, plus plus again we get plus k p, yes, and v of, yes, here we get v, yes, v0 t, this one get. Okay students, yes, clear. Here we get minus of this is, that is we get this one is equal to, okay, because here is minus of, because when this minus of this is, then when cos px is also minus is plus, so this become kp and v0 t. Okay students, now here is also given as v0 t, which is given here is v0, yes, in your question it is given as v0. Okay, so this is equal to or this is equal to v dv, yes, dv, yes, sine transform by dt, yes, plus k p square v, yes, sine transform is equal to k, yes, k p and v0. Yes, you have clear. Okay students, so this is the linear differential equation of first order. Okay, so the integrating factor is in this, here is the solution is f of f is equal to e to the power, yes, k p square dt, yes, clear. So this is equal to e to the power k p square t, yes, clear. And therefore the solution is, hence its solution is, hence, yes, its solution is hence its solution is v, yes, s sine transformation and e to the integrating factor e to the power k p square t is equal to c integrating constant plus integral of k, yes, k p and v naught, and also the integrating factor e to the power k p square t and dt. Yes, okay students, clear. And now we also operate the conditions. Yes, now here vs, which is yes, clear, k and p square, this integrating factor, and here is c kp v0, which is given e to the power this, clear. Now this can now be using the some conditions. Yes, here is okay. Now when, yes, here is okay, conditions is when t is equal to 0, then V sign transformation of this is becomes 0. Yes, students, clear? And then this is equal to when V is 0, since it is given that since V is equal to 0 when T is 0. Yes, V is 0, you get a question, this is given. Okay, and now let us substitute this equation as the solution of this equation. We have right here is C of this is, that is integrating of this is, now integrating this equation can be also get, no, we can also integrating this equation, this is we get also again we get Vs e to the power k p square t, which is equal to C or plus, yes, and here we get integrating this is with respect to t, that is we get here is kp square dividing this square, so we get here is v0 by p. Okay, students, and e to the power k p square. Let us, this equation is 1. Yes, is it clear? Because if you integrating this, then this 2 divided by kp square, then kp is cancelled out, it become this one. Okay, yes. Now from equation number 1, yes, using from 1, yes, from 1, yes, v s is e to the power, yes, e to the power from 1 here, e to the power k p square t is equal to v0 by p, and here is again e to the power k p square t minus 1. Okay, so this we get this is, that is Vs, yes, which is equal to we get V0 by P, and here is again we get V0 by P, and this we get 1 by dividing this term, that is 1 by 1 of this is cancelled out, and so 1 minus of, yes, so this is 1 minus e to the power minus k p square t. Yes, students, clear? I think you have cleared all these steps. Vs is equal to v0 by p, yes, and 1 minus this one. Okay, now we apply, okay students, now we apply the inversion formula. Yes, now applying inverse, yes, Laplace inverse Fourier transform, yes, we have what is v is equal to, yes, Fourier transform of v, which is 2 by pi, yes, 2 by pi, and v0 and 0 to infinity 1 minus e to the power minus k p square t, and divided by p, yes, divided by p sine px, yes, dp. This is the inverse Fourier transform. Yes, students, clear? Now this is again can be written as 2, yes, v0 by pi, and here is, this can be written as integral from 0 to infinity sine px by p dp minus 0 to infinity e to the power minus k p square t by p sine px, not here, dp, okay, dp is here, dp, not x, okay, here is dp, and so we know the integration of this is, okay, so we get, this is, here is 2 by pi, yes, v0, and here we get the value of this is pi by 2 minus 0 to infinity e to the power minus k p square t divided by p sine px dp. Okay students, yes students, applying the inverse formula we get v is equal to this one. This is your question. Yes, using the Fourier sine transform, solve this partial differential equation using these conditions, and now we get, yes, this is equation number 1, and now we get the solution. It's this one. Yes students, thank you, and next video I have also defined some other questions of the Fourier transform. Okay, thank you.